Alrighty, function composition. Function composition is basically just plugging one function into another function. And there are two ways to write it mostly. This open circle in between them is not an O. It's a, I don't know, function composition circle. Some people do say fog. Mostly they're kidding, but you would read this f of g of x. And that kind of makes a little bit more sense when you write it this way. F of g of x. I find this notation much clearer. So if I get a problem that looks like this, I will usually rewrite it like this. So let's see. What that means, g of x is inside f. So I have to take g of x and plug it in to f of x. So f of x says stuff squared minus 1. Stuff squared minus 1. And g of x is the stuff. G of x is x minus 1. So I end up with x minus 1, quantity squared, minus 1. So all I need to do is square and then maybe simplify. X minus 1 squared is x squared minus 2x plus 1. And then I have my minus 1. I'm going to combine my like terms and get x squared minus 2x. So if you would please do it yourself, I gave you slightly simpler, nice linear functions, and I would like you to find h of k of x and k of h of x. So one inside the other and then switch them. The last thing I want to talk about is function inverses. So the inverse of a function just switches the x and y coordinates of every single point. So if we wanted to go from f of x to f inverse of x, and notice the notation. Unfortunately, there are only so many ways to write things. I know sometimes this doesn't mean the reciprocal. It means the inverse. And so if all the points in f look like x comma y, in the inverse of f, they're going to look like y comma x. And if I write that in function notation, you have some point x, and then you plug that into the function and you get out an output. Here, for the inverse, the output comes first and then the input. Well, on the original function. So how the heck do you find the inverse of a function? You switch the x and y coordinates and isolate y. So if f of x is x plus 1 over x plus 2, we're going to find the inverse of f of x, or f inverse of x. First thing I'm going to do is rewrite this as y equals x plus 1 over x plus 2. Alright, now I'm going to switch my x and my y coordinates. So x equals y plus 1 over y plus 2. Now I'm going to move someplace where I have a little bit more room. Oh boy, this should look pretty familiar, right? It's a problem I did earlier this week. I have y's on the top and the bottom of my fraction, and that's just not going to work at all. So what I need to do is multiply both sides by y plus 2 so that I can get it out from under here. So I have x times y plus 2 is equal to y plus 1. I will go ahead and distribute my x, so I have x times y plus 2 times x, and that equals y plus 1. Now I have a bunch of terms with x. Well, 2. That's not really a bunch, is it? I have 2 terms with x, and I've got a couple terms, oh my gosh, 2 terms with y. Y is the thing I'm trying to isolate. And a couple terms that don't have y. So I'm going to get all my y's on one side and everything else on the other side. So to do that, I want to get rid of 2x. I'll subtract 2x from both sides. And I need to move my y to the other side, so I'll subtract y from both sides. Bye-bye. Bye-bye. So over here I have 1 minus 2x. I do have xy and I have minus y. I can't do that subtraction because I don't know what x is. So all I can do is write it down, xy minus y. Well, I noticed that both of these terms have a y, so I'm going to factor that y out. This is y times x minus this is y times 1. Alrighty. Now to get y alone, all I have to do is divide both sides by x minus 1 so that I get y equals 1 minus 2x divided by x minus 1. And what the heck does that look like? Well, graphically, a function and its inverse are mirror images across the line y equals x. When you switch those x and y coordinates, you end up with a function that mirrors across that y equals x line. So let's go see what that looks like in GeoGebra. Okay, here we are in GeoGebra, and I'm going to graph f of x equals x plus 1, x plus 1 divided by x plus 2. Wow, that's complicated looking. Now I'm going to graph y equals x. And if I were to graph the inverse, it should mirror across this line. So it's probably going to have a bit that mirrors like that. And this part would mirror down here. So let's see. I'm going to make a slider. I'm going to say s equals 1. And if I click on it, it'll become visible. And now I can mess around with it. Let me mess around with its properties. I want the slider to go from negative, can I type? I don't know, negative 10 to 10. I think I'll have an increment smaller, 0.001. And I'm going to make it wider. Let's make it 300 pixels wide. Okay. I think I'll also make this line fat and dotted. That's our mirror line. Why didn't you change? I changed you. Object properties with 300 pixels. There we go. I had to hit enter. Good to know. Okay. So I can slide. Wow. If I select my arrow tool, now I can slide S around. We are experiencing technical difficulties. Okay, time to try this again. No, I don't want to save those stupid changes. I don't want to save those stupid changes either, dang it. Okay. Here we are in GeoGebra, and I am going to graph our original function, f of x equals x plus 1 divided by x plus 2. That's very complicated. And I'm going to graph the line y equals x. And I need a slider. I'm going to use the letter S for slider. S equals, it doesn't matter, random number. How about 1? That's a lovely number. If I click this little button here, it becomes visible and I get this little slider thing. And that's great, but it's kind of small. So let me change some things. First, I want to be able to slide it between negative 10 and 10. I want to be able to see my window. I also want the increment to be smaller, so it moves by smaller pieces. Increment, wow, that's not working. 0.01. And I'm going to make it 300 pixels wide, so it's bigger. Okay. Here we are. Now, I can slide S back and forth. Okay. So let's make a point P. P is equal to, and let's say that whatever S is my x coordinate, and then f of s is my y coordinate. So where's P? Well, here's P. See P moving over there? I'm going to make P nice and big. Well, I'm not. Yeah. Style. Make it big. Okay, there's P, that ginormous dot floating around, and as I drag this back and forth, you'll be able to see it. Okay, now the inverse would be to switch my x and my y coordinates. So this was s comma f of s. I'm going to swap those. I'm going to say let's make point Q be equal to f of s comma s. So now as I drag S, you see this point Q floating around down there. I'm going to turn on tracing. And let's see what happens as I drag. I'm going to try and drag it slowly so it makes a good trace. Okay. Look at that. It's mirroring. Okay. You can see how this bit gets mirrored here, and this far away bit gets mirrored here. Now if I were to graph that function that we found, the inverse, y equals, what did we find? 1 minus 2x divided by x minus 1. Hey look, it's a perfect overlay. Isn't that cool? For your do-it-yourself, I would like you to find the inverse of f of x. It's a nice linear function. And then I would like you to graph f of x, its inverse, and the line y equals x all on the same graph. And you should end up with the function and a mirror reflection across this line. Alrighty, I'll see you in class.